Hey everyone, welcome back to the channel. Today we're completing our messaging series with a full Amazon SQS interview deep dive. SQS is the fully managed serverless queue on AWS, no broker to run, effectively infinite scale, and it shows up in almost every cloud and system design interview. We'll cover the 8 topics interviewers ask about most: standard versus FIFO queues, the message lifecycle and visibility timeout, short versus long polling, dead letter queues, SNS Fan-out, deduplication and ordering, scaling limits and cost, and when to choose SQS. For each topic, you'll get a simple mental model, the key technical details, and the trade-offs that make your answer sound senior. This video completes the trilogy with our Kafka and RabbitMQ deep dives. Links in the description. Let's jump in. Topic 1. Standard versus FIFO queues. SQS gives you 2 queue types with very different guarantees. Standard queues offer nearly unlimited throughput and at least once delivery, but only best effort ordering. Messages can arrive out of order and occasionally be delivered more than once. They are the default for most decoupling and fan-in workloads. Think of standard as a huge open mailroom. Letters get processed fast, but they may be handled slightly out of order or occasionally copied twice. FIFO is a single file ticket line per customer, strict order, and each ticket served exactly once. FIFO queues guarantee strict ordering within a message group, plus exactly once processing through deduplication, at the cost of much lower throughput. And notice, ordering is per message group ID, so unrelated groups still process in parallel. If that reminds you of Kafka partition keys, that's exactly the right instinct. Say that in the interview. So how do you decide? It comes down to whether order and deduplication actually matter. If your consumers are idempotent and order is irrelevant, standard is simpler and scales infinitely. If you're processing sequential commands per entity, say, updates to the same order, FIFO is worth the throughput trade-off. Topic 2. The message lifecycle and visibility timeout. This is the most important SQS concept because it works differently from every broker we've covered. SQS does not push messages, and it doesn't hold per consumer acts like RabbitMQ. Instead, a consumer pulls and receives a message, and the queue then hides that message from other consumers for the visibility timeout. The consumer processes it and, on success, explicitly deletes it. If it doesn't delete in time because it crashed or was too slow, the message becomes visible again and another consumer picks it up. That's how SQS achieves at least once delivery. The perfect analogy is a library reservation shelf. When you take a book to read, that's the receive. It's marked on hold, so nobody else can take it. That's the visibility timeout. If you check it out, that's the delete. It's yours. But if you wander off and the hold expires, the book goes right back on the shelf for the next person. Choosing the visibility timeout is the classic tuning question. Too short, and a slow but healthy consumer's message reappears and gets processed twice. Too long, and a genuinely failed message takes ages to be retried. The pro move. A consumer that needs more time can extend the timeout dynamically with changed message visibility, essentially a heartbeat. And because failed messages always reappear, SQS consumers must be idempotent, with repeatedly failing messages routed to a dead letter queue, which we'll cover in a moment. Topic 3. Short versus long polling. When a consumer calls receive message, SQS can respond in 2 modes. Short polling, wait time 0, queries a subset of servers and returns immediately, even when there's nothing there. That means frequent empty responses, more PI calls, and higher cost. Long polling, a wait time between 1 and 20 seconds, tells SQS to hold the request until a message arrives, and it queries all the servers. Here's the analogy. Short polling is opening the fridge every few seconds to check for food, wasteful, and you might even miss the back shelf. Long polling is asking someone to tap you the moment food appears, up to 20 seconds. Long polling is almost always the right answer for 3 reasons. It dramatically cuts empty receives, which are build-up PI requests. It lowers latency, because the message returns as soon as it appears rather than on the next poll, and it reduces the false empty responses caused by SQS's distributed design. AWS recommends enabling it nearly everywhere, either per receive call or as the queue default. Topic 4. Dead letter queues. An SQS dead letter queue is just an ordinary queue designated as the destination for messages that fail processing too many times. You attach a redrive policy to the source queue, specifying the DLQ and a max receive count. Once a message has been received and not deleted that many times, SQS moves it to the DLQ automatically. Picture returns desk in a warehouse. A package that fails delivery a few times gets pulled off the normal conveyor and set aside, where staff examine why, fix it, and reintroduce it, instead of it circling the belt forever. That's what a DLQ does for poison messages, ones that always fail, which would otherwise be redelivered endlessly, eating throughput and blocking healthy traffic. The DLQ becomes a quarantine you can monitor, alarm on when its depth rises above zero, inspect, fix, and then redrive messages back to the source queue once the bug is resolved. 2 details for bonus points. A FIFO source queue needs a FIFO DLQ, standard needs standard, and always set a longer retention on the DLQ than the source, so you have time to react. Topic 5. SNS plus SQS Fan-out. Remember, SQS queues are point-to-point. Each message is processed by one consumer of that queue. So how do you deliver the same event to multiple independent subscribers? You put Amazon SNS, a pub subtopic, in front and subscribe several SQS queues to it. One published to the topic fans out to every subscribed queue, and each queue is consumed independently by its own service. It's a press release sent to a distribution list. Every news outlet, every queue, gets its own copy in its own inbox and acts on it independently at its own pace, while you, the sender, only send it once. This decouples producers from a growing set of consumers. Adding a subscriber is just subscribing a new queue to the topic. No producer changes. Each queue gets its own retry behavior, its own visibility timeout, and its own DLQ, so a slow or failing subscriber never affects the others. 2 refinements worth mentioning. First, SNS message filtering lets each subscription receive only the subset of messages matching its attribute filters, so consumers aren't drowning in irrelevant events. And second, if you need ordered fan-out, SNS FIFO topics deliver to SQS FIFO queues while preserving both ordering and deduplication. Topic 6. Deduplication and ordering in FIFO queues. FIFO delivers its 2 guarantees through 2 IDs. Ordering is governed by the message group ID. Messages sharing a group ID are delivered in strict order, one in flight at a time per group, while different groups process in parallel. Choosing the group ID per order per customer is exactly like choosing a Kafka partition key. It sets your granularity of ordering versus parallelism. The bank analogy makes both IDs stick. The group ID is assigning each customer their own single file queue at the bank. Within a customer, everything happens in order, but many customers are served in parallel. The deduplication ID is the bank ignoring a duplicate deposit slip with the same reference number. Within a 5-minute window, SQS treats any message with a repeated dedup ID as a duplicate and silently drops it. You either supply that ID explicitly, a business key, or enable content-based deduplication, which hashes the message body. The payoff producer retry has become completely safe. And the cost, as always, is throughput per group serialization and the dedup machinery cap FIFO well below standard queues, mitigated by batching and high throughput mode. Mention that trade-off unprompted, and you sound like someone who has actually run this in production. Topic 7. Scaling, limits, and cost. SQS is fully managed and scales automatically. Standard queues handle effectively unlimited throughput with zero provisioning. There's nothing to size, nothing to cluster. You pay per request, and a batch of up to 10 messages counts as one request, plus data transfer. Think of it as a paper parcel courier that scales to any volume on its own. Now the numbers interviewers expect you to know. Maximum message size, 256 kilobytes. Larger payloads use the extended client library to store the body in S3 and pass a pointer. The classic claim check pattern. Retention, 4 days by default, 14 days maximum. After that, messages are discarded. In-flight messages, received but not yet deleted, are capped at 120,000 for standard and 20,000 for FIFO. and delay seconds can postpone delivery by up to 15 minutes. Cost control in SQS boils down to one idea: reduce the request count. Long polling avoids paying for empty receives and batching your sends, receives, and deletes. 10 messages per call cuts the per message cost roughly tenfold, shipping 10 parcels in one box instead of 10 separate shipments. Our final topic: when should you use SQS? It's the right choice when you're on a WS and 1-0 operations, infinitely scaling queue for decoupling components, buffering bursts, and distributing tasks to workers without running, patching, or clustering a broker yourself. It integrates natively with Lambda, ECS, SNS, and the rest of the WS, and you pay only for what you use. It's hiring a fully managed courier service instead of running your own fleet. But SQS is intentionally simple. It lacks the rich routing of RabbitMQ, no topic or headers exchanges. You compose with SNS for Fan-out, and it lacks the replay and stream processing of Kafka. Consumed messages are deleted, and retention tops out at 14 days. So here's the trilogy decision rule to close any messaging interview: complex routing, RabbitMQ; a durable, replayable event log or high-volume stream processing, Kafka or Kinesis and MSK on a WS; straightforward producer-worker queuing with zero infrastructure, SQS. Keep that one ready. And that completes both this deep dive and our entire messaging trilogy. Today we covered standard versus FIFO, the visibility timeout, long polling, dead letter queues, SNS fan-out, deduplication and ordering, the limits and cost model, and when to choose SQS. If this series helped you, hit like and subscribe, and check out the Kafka and RabbitMQ deep dives on the channel. For the full question bank with diagrams and mock interviews, head to prepforge.net. Good luck with your interview. You've got this.